Hi guys, welcome to section 3.2, which is called complex numbers. Before we talk about complex numbers, we need to learn an important part of complex numbers, which is imaginary numbers. So we are given these three equations to begin with, and it says solve each equation and tell how many real solutions it has. So I have x squared equals 1, x squared equals 0, and x squared equals negative 1. Now we know that if we want to undo x squared, I take the square root. So I would be doing that in every one of these equations. So essentially I'm asking myself, what is the square root of 1? What is the square root of 0? And what is the square root of negative 1? Now using real numbers, we know that the square root of 1 could be plus or minus 1 because a positive 1 times itself gives us a positive 1 and a negative 1 times itself gives us a positive 1. So this equation has two real solutions. They are positive and negative 1. Now, moving on to the square root of 0. 0 has only one square root, it is 0. So this has one real solution. When we go to the last one and we're trying to take the square root of negative 1, we run into an issue. We have no real number that multiplies by itself to give us negative 1 because remember, when I take a negative times a negative, I get a positive. So negative 1 times negative 1 gives me a positive 1. That was the square root in our x squared equals 1. And then obviously 1 times 1 gives me a positive 1. So this has no real solution. And we've accepted that until today. We have not been able to solve equations like this using real numbers, so by creating a new type of number called imaginary numbers, mathematicians allowed for solutions for equations like x squared equals negative 1. Now, one place in the real world where imaginary numbers are used is electrical engineering, so we can talk about that in class. So basically, because I'm going to allow for imaginary numbers, I can solve any quadratic equation. So let's first look at the definition of imaginary numbers. They are just the square roots of negative numbers. And they can be written in the form b times I, where b is a non-zero real number and I is called the imaginary unit, which represents the square root of negative 1. So I'm going to write that here and make it very prominent because that is very important for us to know. I is the square root of negative 1. So this solves our problem of not being able to take the square root of negative numbers. Okay, so I just have some examples of what imaginary numbers can look like. And as you see, most of the time we have an I written after the number. But when we have a radical, like here, I rad 2, we put the I in front so it doesn't get mistaken to be under the radical with the 2. Otherwise, it follows the number like a variable would. Okay, let's look at 3. It says find each power of the imaginary unit I, knowing that I is the square root of negative 1. Define each as real or imaginary. So first of all, we have I to the first. That's just I, and that's obviously imaginary. Then we have I squared. Okay, I squared is I multiplied by itself, and if I is the square root of negative 1, I could actually just put the square root of negative 1 in there, squared. And what happens is, we know that squared and square root cancel each other out, so I end up getting negative 1. So I squared equals negative 1, and that's a real number. So I to the first is I squared is negative 1. I cubed I can write as I squared times I, and we just found out I squared is negative 1, and then times I is just a negative I. So I cubed is negative I, which is imaginary. Okay, I to the fourth, I could rewrite that as I squared times I squared. And we know that I squared is negative 1, so I can multiply negative 1 times negative 1 and I get positive 1. So I to the fourth power is the positive number 1, and that is real. We're going to continue that table in class tomorrow so we can see a pattern on the powers of I. But one power that I really want you to take note of is that I squared right here equals negative 1. And I hope that makes sense because we got I by taking the square root of -1. So don't ever forget this. I squared equals -1. All right, especially when we start squaring imaginary numbers. We're just going to do 2 of these and we're going to do the other 2 in class. So find the square of each imaginary number. So letter A is 5i. If I square that, I could write that as 5i times 5i, which is 5 times 5, 25, I times I squared. Remember, I squared is -1, so actually my square of 5i is -25, which should make sense because remember, I comes from taking the square root of a negative number. Okay, let's do B. If I square -I times the square root of 2, that would be, you can also apply the the power separately if you would like. I'm just doing this a little different than I did the first one. Like that. So a -I squared is a positive I squared, and rad 2 squared is just 2. We know I squared is -1, and -1 times 2 is -2. Okay, so basically if you're squaring I, it just makes a number negative, and then you square the number that's next to it. All right, we will do the next 2 in class, and I want to get to the big thing here, is finding imaginary solutions of simple quadratic equations. The whole point, as we knew in the beginning, is to have I, now we can take the square root of negative numbers, thus we can solve quadratic equations that are solving by taking the square root of a negative number. So in example 5, it says, solve the quadratic equation by taking square roots. Allow for imaginary solutions. So letter A, I have x squared plus 12 equals 0. I'm going to subtract 12. So now I have x squared equals -12. I'm to the point where I'm going to take the square root of both sides. Now remember, when we apply the radical, we always have to account for the positive and negative square root. Well, I'm asking for the positive and negative square root of -12. So using our product property of square roots, I could write this as plus or minus the square root of -1 times the square root of positive 12. The reason I'm doing that is because what I have now is plus or minus I times the square root of 12. I'm not done because I can reduce this radical, square root of 12. We know that. I can rewrite that as the square root of 4 times the square root of 3. The square root of 4 is 2. I'm going to write that in front of the I. So that's 2i rad 3. So I separated that all out, but I hope you know that when we have a negative number and we take the square root, it's going to have an I in it. So I could have just simplified the rad 12 to 2 rad 3 and stuck an I in there. All right, we're going to do B, and then we're going to call it a day, and we're going to finish the rest in class. 4x squared plus 11 equals 6. I'm going to subtract 11. So I have 4x squared equals -5. Then I have to divide by 4. And I get x squared equals -5 4x. Now I take the square root of both sides. And remember, when we take the square root of a fraction, first I put my plus or minus. I'm going to take the square root of -5 on top over the square root of 4. 5, if I just think square root of 5, there's no reducing that radical. But that negative, I have to separate that and think square root of -1 times square root of positive 5. We know the square root of -1 is I. So that's going to be I times the square root of 5 over the square root of 4, which is 2. All right, guys, I hope you get a little insight into the number I, and we'll talk more about it in class.